Correlation. Pearson's correlation coefficient. This topic is a part of Biostatistics and Research Methodology in pharmaceutical science. The content of this topic includes definition of correlation, types of correlation, Karl Pearson's coefficient of correlation, and multiple correlation. Definition. Correlation is a statistical tool that studies the relationship between two variables. Two variables are said to be correlated if the change in one variable results in a corresponding change in the other variable. For example, the study of enzyme concentration and enzyme velocity, concentration of solution, and absorbance. Correlation is used to characterize the quantitative relationship between variables. Correlation analysis assumes a linear or straight-line relationship between the two variables. Types of correlation. Positive and negative correlation. If the values of two variables deviate in the same direction, for example, increasing the value of one increases the value of the other, it is a positive or direct correlation. If the values of two variables deviate in opposite directions, it is a negative or inverse correlation. Linear and nonlinear correlation. Correlation is said to be linear if, corresponding to a change in one variable, there is a constant change in the other variable over the entire range of values. Linear correlation relationship. Y is equal to A plus BX. Correlation is said to be nonlinear if, corresponding to a change in one variable, there is no constant change in the other variable over the entire range of values. For example, exponential correlation, as shown here in plot. Correlation diagram or scatter diagram. When two variables move together in exact proportion, it is perfect positive correlation. When a strong direct relationship between two variables, it is high degree of positive correlation. When two variables tend to increase together but with a weak, inconsistent relationship, it is low degree of positive correlation. Similar way, there is perfect negative correlation, high degree of negative correlation, low degree of negative correlation, no correlation, also known as zero correlation, means there's no noticeable linear relationship or pattern between two variables. Pearson correlation coefficient. Symbol is small r. This coefficient is also known as Karl Pearson's coefficient of correlation. It is the covariance method, Pearsonian correlation coefficient, or product moment correlation coefficient. It is a mathematical method for measuring the intensity or the magnitude of the linear relationship between two variable series. The equation is R is equal to covariance of xy divided by sigma of x and sigma of y. Its simplified equation of Karl Pearson's coefficient of correlation, best used for the calculation Exercise. Data on diastolic blood pressure and cholesterol levels of 10 randomly selected men are shown in the table. Find a correlation between diastolic blood pressure and cholesterol level. The table contains diastolic blood pressure and cholesterol values. So, these are two variables, and we have to find correlation between these two variables. The equation of coefficient of correlation is here. In this equation, n is the total number of observations, that is 10. X and y are the values of two variables. Let us take y as diastolic blood pressure and x as cholesterol. To solve the equation, we need to calculate sigma x and sigma y, and further, we need to extend column to calculate values of xy, sigma of x square, and sigma y square. Calculate the values of sigma x and sigma y and sigma xy, sigma x square, and sigma y square. Now put all these values into the equation of coefficient of correlation. When we solve this equation, the answer obtained is 0.809. Result: correlation in diastolic blood pressure and cholesterol levels is 0.809. Conclusion: there is a fairly high degree of positive correlation. Properties of the coefficient. Limits of R cannot exceed 1 numerically, so R value always lies between -1 to +1. Correlation coefficient is independent of the change of origin and scale. Change of origin means some value has been added or subtracted in the observations. Change of scale means some value is multiplied or divided to observations. The coefficient of correlation is the geometric mean of two regression coefficients, as given in the equation below. The coefficient of correlation is equal to the square root of bx on y into by on x. Two independent variables are uncorrelated, but uncorrelated variables need not necessarily be independent. If the variables x and y have a linear correlation with the equation ax plus by plus c is equal to 0, then the correlation is either +1 or -1. If a and b are of opposite sign, then R value is +1, and if a and b are of same sign, then R value is -1. Assumptions of Pearson correlation coefficient. Correlation analysis assumes a linear or straight line relationship between the two variables. Each of the variable series is being affected by a large number of independent contributory causes, of such a nature as to produce a normal distribution. If the two variables are entirely independent of each other and not related in any fashion, then there cannot be any correlation between the variable under study. If the study result shows R is not 0, this correlation is called a chance correlation, or spurious, or nonsense correlation. For example, high chocolate consumption tends to produce more Nobel Prize winners. R, found in this study, is equal to 0.791. Significance of R value. The value of R lies between minus to plus 1. Values vary from -1 to +1. Positive values of R indicate positive correlation between the two variables. That is, changes in both variables take place in the same direction. Negative values of R indicate negative correlation. That is, changes in the two variables taking place in opposite directions. When R is 0 indicates that there is no association between the two variables. When R is +1, it indicates perfect positive correlation. When R is -1, it indicates perfect negative correlation. The value of R nearer to +1 or -1 indicates high degree of correlation between the two variables. Multiple correlation. Symbol is capital R. It is correlation between 3 or more variables. In case of 3 variables, x1, x2, and x3, multiple correlation coefficient will be R1.23, R2.13, and R3.12. R1.23 is R with x1 as a dependent variable and x2 and x3 as independent variables. R2.13 is R with x2 as a dependent variable and x1 and x3 as independent variables. R3.12 is R with x3 as a dependent variable and x1 and x2 as independent variables. Equations of multiple correlation are given here. Within these equations, R12 or R21 stands for correlation between first and second variable, and R23 or R32 stands for correlation between second and third variable. The significance of multiple correlation. R lies between 0 and 1. Multiple correlation coefficient can never be negative. R is always positive. If R is 1, there is perfect correlation. If R is 0, there is no correlation. If R is closer to 1, there is high degree of correlation. Exercise. In trivariate distribution, R12 is 0.7, R13 is 0.61, and R23 is 0.4. Find all multiple correlation coefficients. Put all correlation values in multiple correlation equation, and on solving the equations, we will get the answer. You can refer to these mentioned books for this topic. Fundamentals of Statistics by S.C. Gupta. Pharmaceutical Statistics, Practical and Clinical Applications by Sanford Bolton. Please take a note on important study questions. Thank you.